2.2.2 The normal distribution. You all know roughly what a normal distribution is. In this part we're going to learn a little bit more about this very important distribution. To represent such a distribution with R, we're going to use the denorm function that gives the density of a normal distribution. By default, mu is equal to 0 and sigma is equal to 1. First, we're generating some coordinates on the x-axis, 200 equally spaced numbers from -4 to 4, using the sec function. The name of the function stands for sequence. Then, with the denorm function, denorm stands for density plus normal. We're generating the values of the density function corresponding to these x coordinates, and that you have seen in slide 19. Finally, we plot these two sequences of numbers. Let's now play with the pnorm function that gives the distribution function, the way realizations are distributed. In other words, for a given real number x, pnorm provides the probability that a random variable x that follows our normal distribution, with mu is equal to 0 and sigma is equal to 1, by default, takes our value below x. Exercise. Have a look at the qnorm function by running the following line that provides the documentation associated with the function. For another function, change the name of the function. With the qnorm function, provide the symmetrical interval, with respect to 0, that contains 90% of the realizations of our normal distribution, with mu is equal to 0 and sigma is equal to 1.